Okay, so this question helps explain the principles of constrained motion and how using pulleys, the use of pulleys can be incorporated into the work that we've done so far. And this question is split into two parts. You've got the configuration shown here, and you've also got a second configuration which pretty much looks like this. Your tractor going this way, and your pulley here. Instead of just one rope here and two here, then in the second example you have two. You have a pulley connected here and one rope down to the mass. And the question is, for the same speed of A, which system allows the mass B to rise the fastest? Now, you may already be able to see this intuitively, but we're going to go through how we can prove that. Okay, so for the first part, you've got the system here. As mentioned in class, the important thing is to come up with an expression for the length of the cable in terms of the quantities that you know and the quantities that are going to change, crucially. So for example, you know that the length of the cable L is going to be twice the difference of H and Y, so we use our Y coordinate starting from the bottom. So as this goes up, Y increases, and then this length here is going to be H minus Y, this distance is going to be twice that because we've got the rope wrapping around and going back up to the pulley, plus L. Now L we can find using Pythagoras to be H squared plus X squared square root. Now if we differentiate that, then all these little bits that are constant, so the bit around the pulley there, the bit around the pulley there, are going to stay the same and they'll drop out. And so the only things that will change are going to be these lengths and this length. So we then have to differentiate this expression, which is a little tricky. So the differential of the square root of H squared plus X squared can be decomposed as a chain rule. So because this is the rate of change with time, actually we need this with respect to x, so we have d this by dx times dx dt to get it back into the d this by dt. And this part can be decomposed, or can be rewritten as h squared plus x squared to the half, and the derivative of that is going to be a half times the derivative of what's inside the bracket, so x squared is times 2x, and then the exponent minus 1, so minus a half. So combining all of that, you have half times 2x, so x, 1 over h squared plus x squared times dx dt, so x dot, which is what you have here. So then you have the expression relating y dot and x dot, and of course y dot is VB and x dot is VA. That's the tractor going horizontally to the right, and this is the mass being lifted vertically upwards. So if you have this goes around to the other side, and you have 2VB is equal to x VA over the square root of h squared plus x squared. So this is the expression to find the rate, the link between the velocity of the tractor and the velocity of the mass. Now we do the same for the other configuration. Okay, so in this configuration we now have two loops of the rope on the diagonal and one on the vertical. And so our equation for the rope is then h minus y here, so this is h minus the increasing height y, with our origin again at the bottom here, and 2l, so h minus y plus 2l, and of course the bits that are constant. Now L, as we've computed before, is x squared plus h squared. Take the differential of that, because we know this from above, we know that the differential of this is simply this, that's coming from there, the previous part. So this time it's a bit quicker. We can say that on this occasion minus y dot, which is VB of course, is equal to this expression, and here of course x dot is VA. So you get your expression for VB to be 2x times VA over square root x squared plus h squared. So from part A, the vertical speed of the mass, the link between the speed of the mass and the tractor was as follows: 2VB is equal to x VA over this. So then we can work out that in relative to the first one, the second one, the vertical speed VB is going to be moving 4 times faster than it was in part A, because this factor 2 and this factor 2 here combines to give you an extra speed which is 4 times greater. And that's the answer to the question.